Hi guys, today we're going to look at some different lines and in some ways some easier ones, but ones that you have to remember anyway. And they are the ones that are horizontal, vertical, and I've put diagonal lines, but that's not strictly a mathematical definition, but you'll see what I mean when I come to those. Right, let's first of all have a look at some vertical lines. Right, if I put a line through here, excuse my shaky hand, and then start to think about all the points that it goes through. Well, it goes through here, 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 here. Lots and lots of points. And in fact, it's a line because that's like a trillion different points joined together in between there and there. In fact, an infinite amount. So we can't exactly say all of the points are on it, but I'm just going to pick some of the integer, which means the whole number ones. So this one here is 3, 1. This one is 3, 2. We've got 3, 3. This one is 3, minus 1. 3, minus 3. And the thing you should see for all of them is that this is always 3. So if you thought about some general coordinates, the coordinate, so we have the x coordinate coming before the y coordinate, so we've got x and y. I'm saying that the x is always 3. Agreed? So this first one is always 3. X is always 3. Now, as a mathematician, I don't like writing a lot. So instead of saying x is always 3, I'm going to say x equals 3. And I think that's a much neater way of doing it. So if I was to draw one over here somewhere, it doesn't matter where I draw it actually. But if you looked at all these points here, minus 4, 1, minus 4, 2, minus 4, 3, minus 4, 4, minus 4, 5, and then going down, you'll start to easily see that they're all going to be minus 4 something. So I'm going to say that that line is called x equals minus 4. And a thing to notice is that it crosses the x-axis at minus 4. So if I was to just do one more, let's put a line just here somewhere, you can see that it crosses the x-axis at 1, so this line is called x equals 1. Okay, nice and easy. So you would expect that we would have a similar thing going on for horizontal lines. So if I look at this line here and consider some of the points along it, I can see that I've got 0, 2 there. This is 1, 2. This is 2, 2. Desmond, or what a ballerina might wear. This is 3, 2. So always the second number is 2. So in terms of x, y, this second number is 2. So this line is called y is equal to 2. And you'll notice it crosses the y-axis at 2. So if we bear that in mind, and what we've learned from the x's, I can look at some of these others and say, okay, that line there, that crosses the y-axis at minus 1, so that's y equals minus 1. Whoops. This one crosses the y-axis at -5. That's y equals -5. So it's dead easy, really. Vertical line across the x-axis at a number. That line is then x equals. A horizontal line across the y-axis at a particular number. So that line is called y equals that number. Really, really easy. Now the ones I want to go on to are these ones in particular. So I said diagonal, although that's not really a true definition, because we look at loads of sloping lines, and a diagonal is actually to do with inside a 2D shape. But most people are taught that as an idea of diagonal when they go to primary school. Now, if I take the same approach and look at some of the points along this line, I can see I've got 1, 1, 2, 2, 3, 3, 4, 4, etc. And if we go into the minuses, I've got -2, -2, and I've got -4, -4. And you can quickly see what the pattern is there. And the pattern is that the two numbers are the same. And when we go back to think about our x and y, you can say, well, okay, these two numbers have to be the same. That's a long thing to write. I don't want to write all of that every single time. So what I'm going to write is that the y is always equal to the x. So this line is called y equals x. And when you think about y equals mx plus c, it has a y-intercept of 0, and it goes 1 along, 1 up, 1 along, 1 up, 1 along, 1 up. So it could be thought of as y equals 1x plus 0. And that might be another way of thinking about it. But its actual name is just y equals x, because we don't say 1x. If I said to you, what would I say? How many cars have you got? You wouldn't say we have got one. No. That was a poor example. If we were walking down the street and an animal walked across in front of us and I said, what's that? You would say it's a cat. You wouldn't say it is one cat. So we say the same thing, y equals an x. We don't say y equals 1x. Because in language that's not what we use. If there's just one of them, we just have that. We don't say specifically there's one of them. Hopefully that wasn't too confusing, because it wasn't really a major point. Okay, let's have a look at this one here. So going in the opposite direction. And I think many of you will be able to guess what this is going to be. In terms of when we think about opposites, I've drifted a little bit from there. But this point here is -1, 1. This point here is -3, 3. Just so I can fit them in. This one is -5, 5. This one is 1, -1. This one here is 3, -3. So when you've got your x and your y, what's happening is that one is always the negative of the other. So x here is the negative of the y, and here y is the negative of the x. So y equals -x, or x equals -y. And actually they say the same thing. They represent exactly the same thing, but this is what we tend to call it. And in terms of y equals mx plus c, we will say y equals -x, or -1x plus 0. And thinking about the y equals mx plus c, if we shifted this diagonal line up to here somewhere, you can add that y-intercept in. So it's a diagonal line, same gradient. This would be y equals x plus 3 because we're now considering the y-intercept. And this one here, let's go for it just there. Y equals minus x minus 4 because obviously we've got the y-intercept there as well. So these are definitely things that you need to be able to recognize and put down straight away. Vertical lines are always just x equals. Horizontal lines are always just y equals. This perfect diagonal line is just y equals x, but you shift it and you add on the y-intercept. So if it's parallel to that line, you just add on the y-intercept. And here, again, if we shift it, we add on the y-intercept. So if it's parallel, again, we add on the y-intercept. This has a gradient of 1, this has a gradient of minus 1, even though we don't show it here or here. Okay?